Welcome to the cereal disease portion of our tour. We're in front of some winter wheat. We don't know what variety it is, but it's likely radiant just because it's getting hit pretty hard with some leaf spots, particularly tan spot right now. I'm unsure of the rotation, but there's a lot of trash on the ground, so it's a good trap crop for leaf spots. Right now, you know, we're really unsure what impact leaf spots have on yield. Generally, most of our crops, most of our wheat varieties do not warrant control for leaf spots. So we wouldn't necessarily recommend spraying for leaf spots right now. I think the research is a little weak on the area, and we really don't have a good idea on the potential for leaf spots to reduce yield and quality in wheat. They can look bad, but you'll find it working its way up the crop canopy, which is normal for diseases like leaf spots and powdery mildew. But as of today, we are not really sure what impact that they have on yield. So that's an important point, because if you're going to consider spraying for something like leaf spots, then we're really unsure whether you're going to recover that investment on that spray. So keep that in mind when you're being advised or you're considering a spray. I don't think that there's really good data. And as I said, radiant is particularly susceptible. Most of the newer varieties, as we move into them, are going to be a lot better on the disease front. And so you'll see a lot less disease, a lot fewer disease, and a lot less severity than what we're seeing right now.
So a lot of growers use a half rate at herbicide timing, and you're saying,
you know, that there's really a lot of controversy on that half rate of tilt with the herbicides. You know, Kelly Turkington, a colleague of mine up in Lacombe, has been looking at the effect, certainly on the barley side, because that's his area, and he's finding that there's no advantage at all to doing that. And it makes sense, because when you look at any crop development system, you realize, or we do realize, that it's the flag leaf and the flag leaf -1, that's the penultimate leaf, that contribute to the greatest extent to yield. So if you're spraying at a very early stage, you're unlikely to catch those stages anyway.
so save your money and spray a flag instead.
If you're going to spray, if you're going to take any protective steps, and I'll discuss this with respect to stripe rust, but if you can take any protective steps, that's at the stage you want to protect it, pre-flowering. So the next leaf disease that's been of concern in the last, I'd say 8 or 10 years is stripe rust. What happened about 5-6 years ago, the variety Radiant that had the YR10 gene for resistance in it has became susceptible to stripe rust and the prevalent races. And that was because there was a major shift in races in the Pacific Northwestern United States, where most of the inoculum comes from for our spring infection. So what happened is that gene was overcome by the new races, and then we had a real serious issue because the winter wheat was becoming infected earlier on, and then the stripe rust was moving from the winter wheat to the spring wheat, and that is where we're at right now. The good news is that newer varieties of winter wheat are resistant to stripe rust. Rob Graff, our winter wheat breeder, has been really on top of this problem, has made really good progress. So we're really hopeful that the future for winter wheat and Alberta farmers is going to be a lot brighter than what we've seen in the past. But right now we still have a fair number of susceptible varieties around on the winter wheat side. On the spring wheat side, there's good resistance in a lot of our varieties for stripe rust. Okay, Durhams are mostly resistant. We have trouble getting good infection in the field, so there shouldn't be any need for spraying on the Durham wheat side. A lot of our hard red springs like Lillian and Carberry and have excellent levels of resistance, so there's no need to spray there either. So some of those varieties, and you should go to your provincial recommendation lists, check them out, find out what level of resistance you have in your varieties, and then in my estimation, it's a good package to have, is to have that stripe rust, a good strong stripe rust package, so that that in those years where it comes in early or it might overwinter, that's when we want to count on that resistance that these varieties have. Okay.
Dennis, finding any in southern Alberta?
Good question. We just had a report of stripe rust in central Alberta, around the Olds area. There's a couple of fields and some plots up there that have stripe rust. Not a lot of winter wheat up in that area, so we're not anticipating it'll have much effect on the picture down here. We've been out surveying for stripe rust in southern Alberta and we haven't seen it. That's a good sign. So we're waiting for it. Stripe rust, if it comes in late, a good example was last year. Stripe rust, we started seeing it in late June, didn't develop very quickly, and the worst field we saw last year was about 15% infection, which would have had no effect on yield. Okay, so stripe rust often comes in late, and it can have an effect on yield and quality, but if it comes in late, it's not going to have a big effect. Okay, so as I was saying, last year we were out surveying for stripe rust, and what we noticed was that farmers were proactive. They were spraying their fields, okay, regardless of whether they knew whether stripe rust was a problem or not. And I spoke to one farmer, and he said he had spent about $60,000 on fungicide for about 3,000 acres of winter wheat, and he was told by the product salesman that he should apply it twice. Well, so that's what he was doing, and to fast forward, we saw very little effect of stripe rust in either winter wheat or spring wheat last year. So the question is whether or not that type of investment is worth it for the producers. So two things for stripe rust, that if you want to take a take-home message for stripe rust, is to get out in your fields and keep an eye on for it. Okay, make sure that it's in your field before you start looking at control measures. Okay, usually it develops. It has a 20-day lag period. So if we get a spore shower, you're not going to see infection for another 2 to 3 weeks. So that can cause problems for producers, because there's that long lag period. But if you don't see any pustules in your field, it's unlikely that you're going to see a massive outbreak in that field. It'll generally build up over time. And if you do see it, and you know your variety is susceptible, then I would not discourage you from adding spray, particularly if it's early in the season. Now, when we're talking about spraying, as I mentioned earlier, we're not interested in spraying too early, because if it comes in and hits your flag leaf and your flag -1, then you're still not going to get the protection on that leaf if you spray in the seedling stage. Okay, so we're looking at we have a study on station here where we're looking at timing of fungicide application on a variety like Lilium, which is resistant, CDC Imagine, which is in the middle of that resistance level, about intermediate, and Berry, which of course is susceptible to stripe rust. And what we found so far after 2 years is that generally there's no need at all to spray Lilium, because there's no effect of that spray on improvement of yield or quality. Conversely, Berry will show, which is susceptible, will show an increase in yield and quality with the spray. Now, when should you spray on a susceptible variety? It's no use, as I say, to spray too early, because you're not going to protect those last 2 formed leaves. If you spray too late, believe me, it will not improve yield and or quality. Okay, so what we're looking at for an optimum spray is probably just before flowering, and at that stage we get the best effect of a fungicide application. Okay, so timing is important if you've got a susceptible variety, but if you have a resistant variety, we're not seeing any advantage to a spray for a disease such as stripe rust. Intermediate, as I say, CDC Imagine, which is right in the middle there, that's one that you would want to get out and monitor your fields, making sure that if you're not seeing it, it's not going to be an issue. And if you do see it, monitor, make sure it's not building up too rapidly, because it does have genes for resistance, but they're influenced by the environment, so the slight variations in environment can affect the effectiveness of the resistance package in a crop in a variety such as CDC Imagine. So important to remember is it costs a lot of money to put on the fungicides, particularly the newer ones, and so there's a break even on terms of whether you can recover that investment, and those are the decisions, of course, producers have to make, and the more information they have available to them, the more wisely they can make those decisions. Okay?
I got 2 questions.
Yes, ma'am.
Number 1, outbreak at Olds,
Yeah.
fields at Olds, is the theory then that it overwintered there?
That's what we're looking at. In southern Alberta, about 3 or 4 years ago, we had a good outbreak of stripe rust, and we attributed that outbreak to the fact that there was a fair bit of snow, a continuous snow cover all year. And what that does is that protects the lower those first formed leaves, the fall formed leaves, and those are the ones that are going to get infected in the fall. Okay, so that snow cover protects those leaves so that they can survive the winter. And as probably most of you know, stripe rust is an obligate parasite. That means it has to grow on living tissue. If the leaf is dead, it's not going to survive itself. Okay, so if the snow protects those first formed leaves and enables them to survive the winter, the striped rust will survive, and that commonly occurs in the central part of the province because they get a nice blanket of snow. Underneath the snow, it's nice, -2, -3 degrees all winter, perfect for survival. In southern Alberta, we lose generally our snow cover several times during the winter time, and those low temperatures that winter wheat is adapted to will kill those first formed leaves. You'll find them all browned off at the end of the winter and early spring, and the new growth is generally free of the stripe rust. So, and that being the case, we could easily understand how it would survive in central Alberta, but not survive in southern Alberta.
Question number 2 about fungicide timing, and you were saying, wait right till flowering. So now we're getting into the whole fusarium head blight timing. So are you suggesting if you don't have it, you don't think you have it, and of course disease depends on weather, and so wait and just do fusarium head blight timing, or?
That makes sense, doesn't it? It really, you've got a situation where FHB is important in your fields. Then obviously, if you control it at an earlier stage, and I'm unsure of the spray stages for FHB, but it certainly is protecting the flowering and post-flowering tissues. So I would think that it would coincide pretty well with those for control of those two diseases.
And so fusarium head blight, is it moving or shifting?
I was just having this conversation with Dune Polly just this morning, and they're looking at that to see whether or not, based on the level of genetics that we've currently got in our varieties, whether on irrigation or dry land, whether the situation is changing vis-a-vis what we can expect to see under a couple of different agronomic systems, irrigation versus dry land. And I think those type of studies, now that fusarium is here, it's established, now we have to understand what effect it's really having in our rotations, and whether or not we have to take a sort of a global look at how do we control it and how do we best manage it. The varieties of both spring wheat and winter wheat, the new winter wheat varieties generated by Rob Graff are excellent for stripe rust. Excellent. That is, they're better than often in many cases better than what we see in spring wheat. Harpinder is here. He might want to comment on the level of stripe rust or FHB resistance in his soft white and GP classes, but I think they're pretty good.
Well, we're moving into that direction. We have few lines coming in a pipeline, but so far what we have registered, they are not excellent in. We don't have excellent resistance for fusarium.
But
they're tough to breed, and it will take a long time to get into soft white.
Yeah.
So we have lots of lines in the preliminary yield trials that have FHB resistance.
Yeah.
And of course, stripe rust is very important for southern Alberta, and we're improving all together.
Yeah, right.
But also, I'd like to comment on CPS wheat. We have a couple lines they have been registered. One is called AAC tenacious, which has excellent level of fusarium resistance. This is probably the best lines out there among any wheat, and Rob's winter wheat Emerson, which is excellent in for fusarium resistance. Those two stand out from the rest of the lines. They're out there for both spring and winter wheat.
So there's hope on the FHB front, and we're really encouraged and enthused by the progress that's being made on the resistance side. Any other questions?
I hate to put you on the spot. I know we talked, and canola is not your specialty, just because it happens to be that timing for blackleg applications. Did you have a chance to look into that, or?
You know, again, it's all to do with getting out in your field, monitoring whether or not it's starting to build up in your field, and if you feel that it's going, I think it's been shown that fungicide does give a yield and a boost to in canola for protecting against blackleg. So I would encourage again that if producers are seeing it and it's moving in early, then they should be looking at a control measure. But again, make sure we're spraying because we're seeing development in your fields. Just before we go, one of the issues that we're seeing more and more of course, is cereal leaf beetle, and we're starting to see that as a real emerging issue. We see more and more every year as we're out looking in the field. So maybe Hector can comment on cereal leaf beetle as an entomologist. Before I wouldn't want to let him off the hook, and there's some good examples of a lot of cereal leaf beetle damage in the field there if you want to look at it.
The cereal leaf beetle, this is another kind of newish pest. We've seen it in southern Alberta again. We seem to be a magnet for pests, and I think that's because we have such a diversity of crops, and we must be at the right location to get these new insect pests. This is another European, Asian pest that it has been in North America since 1961 in northeast US. Then it's basically now it's everywhere in North America except California, or so they claim. That it's like Alberta being rat-free, they are cereal leaf beetle free. Maybe it's just a myth. But first thing I like to point out is that there is another beetle that is actually a beneficial beetle that looks quite a bit like the cereal leaf beetle. And I'm going to pass this around, and you can see the label there. There's a little paper with the name. The one on the left is the cereal leaf beetle. The one on the right is the soft wing flower beetle. And the one on the right, the best way to distinguish it would be in a live specimen. You catch it in the field. You look at the abdomen, its belly is going to be orange or yellow. The cereal leaf beetle is all black, same color as the wings. So that's how you distinguish this. So I'll pass this around. Soft wing flower beetle, and that beetle is actually a beneficial predator. It will eat other insects. Probably will eat the cereal leaf beetle eggs or larvae. So I'll pass this. So that's the comparison. Okay, so the concern about this pest, and for the first 5 years when we found the cereal leaf beetle, it was considered a quarantine pest, and CFIA had some legislation that prevented the export of hay. It had to be fumigated. I think that has been lifted because it's obvious that we cannot contain the pest. It has appeared in Saskatchewan shortly after we found it in 2005. It appeared in Edmonton last year. We have reports of it in Moosomin in South Saskatchewan in the east, and also even in Manitoba in the very far northwest area. So it's pretty much all over the prairies. So this beetle is kind of a bad news, good news story in some ways. Believe it or not, there is a silver lining and a bit of good news that comes with it. Why we're concerned about these beetles, because it's a very generalist feeder. It will actually even eat your wild oats probably if it has nothing else to eat. So that's, I guess, that's one of the good news. It will attack wheat, barley, oats, pretty much all the cultivated cereals that we have around here. And the problem is that the larvae and the adults, they feed on the same parts. So they can be quite damaging. And the damage caused by these beetles is quite distinctive. You can see that you have damage by the adults. I'll circulate these because you see these kind of long, narrow windows, and there's a complete hole because the adults will actually chew a complete hole. So I will pass this around. This is the adults, and there is a little label telling you what's in the vial. You can see the adults there. You can see they're kind of showy. And the larva will cause these kind of window panes. It's still long and narrow, except this sample came from our lab, and they have pretty much chewed the entire leaf. But you will see these window panes on the tablets around. I guess you've probably seen them before. So this larva. Oh, the vial that has the larva has the good news story that comes with this this pest. You will see several little wasps there. They look like little flies. They are actually wasps, and they are beneficial parasitoids of the cereal leaf beetle. And soon after we discovered the pest, we also discovered this little wasp that actually is quite prevalent and is very effective at controlling the cereal leaf beetle. There are very few cases where we talk about biological control as the primary way to control a pest. In probably all the other insects that we study is either insecticides or host plant resistance, developing something that is resistant to the pest. But in this example with the cereal leaf beetle, there's evidence, and it actually has been shown quite well in the east, in Ontario, Quebec, in New York, and all of the northeast, and also in the Pacific Northwest, where they have had the beetle for a long time. They have also introduced this tiny wasp that goes by the name of Tetrasticus julis, and that's a very long name, so we'll just call it T. julis for short. And I hope you remember that name, because this wasp is actually very, very good at dispersing and finding the larva. It's in one of the vials there where you see the larval damage, and there's quite a few of them there. So this wasp will overwinter in the soil. So if you're tilling the soil, you're probably going to kill a lot of the wasps. So that's another reason not to practice tillage. And also, it's really important that you only spray insecticides in that field if you really have damage that is over the economic threshold for the cereal leaf beetle, because by spraying the insecticide, you are not going to be helping the parasitoid to become established. The economic threshold for cereal leaf beetle, we actually have not validated one here yet. We're going with the nominal threshold from the US, and that threshold is 1 larva per flag leaf. So that tells you the crop stage also. So this winter wheat, for example, is now at the right stage. So if you take 10 stems and you're finding 1 larva per stem, then you'll be at the threshold. If you were finding 1 larva per stem, you actually will see the damage very easily. And the way they determine whether they have damage in the US is actually quite simple and easy. Well, you should still do the counting, but you can get an idea how bad the damage is by simply walking to the field and wearing white pants. And the reason for that is, and you probably will remember this forever now, these beetle larvae are kind of not very clean. You know, they like to cover themselves in their own feces all the time. So they're always moving their feces onto their body, and that's why they look so slimy and they look like little slugs. And that means that they require good humidity. So they're probably not going to be a major issue, I don't think, in the very dry areas, in dryland wheat, but probably in irrigated wheat and in perhaps more central northern Alberta and in the prairies where it's more moist, they could become a major pest. Except that we have this wasp, T. julis, that is very effective at controlling it. And we are seeing levels of parasitism in almost all the fields around here, around 30, 40, even 50%. And we're hoping that with time, and provided we don't start spraying unless we actually have to spray, we can see levels of parasitism that will be 80 or 90% as we see in other areas. We did some collections with Lloyd Dostal a few years ago in the Creston Valley, where we have the beetles and the parasite that was introduced many years ago, and they have 90% of the larvae parasitized by the T. julis wasp. So that's the key message here, I think, is to remember that we do have this wasp around, and if you have fields where you have a lot of larvae, I would appreciate if you let us know, and we can actually release some of the wasps, because we are rearing them in the lab now, and we are sending them to places in the prairies where we don't have the wasp established yet. So I think that's the good news, bad news story about the cereal leaf beetle. Any questions? If anybody would like to see the eggs, I actually do have a vial here and a magnifying glass. You can see, and I actually drew a circle there too. It looks like you would like to see eggs.
I'd like to see the eggs.
Yeah, the eggs are laid on the surface of the leaf, and they're usually laid in single, or sometimes you see two at a time. And when they're laid, they're kind of whitish, then they turn yellow, and then they turn black, and they take about a week to hatch. And when they hatch, it's just very, very tiny first instar larva. It's like a little spot. And then they go through 4 instars, and then they become a pupa. They fall to the ground, and they pupate in the ground. And then they come out, and they will continue feeding for a couple of weeks if they find anything green to eat. And then they go into overwintering. And they usually overwinter outside the fields. They overwinter along the field margins or tree shelters.
Hector's not talking anymore, so I assume you're done.
I'm done, yeah.
Okay, join me in thanking Hector once more.